Hey everyone, welcome back to the channel. In this video, we are going to explore Terraform count meta argument, and we will see how we can leverage count.index to create multiple Terraform resources dynamically. So if you're looking to make your Terraform configurations dry and scalable, this video is for you. So without further ado, let's just understand what is Terraform count meta argument. Terraform's count meta argument allows you to manage resource duplication easily. Instead of manually creating multiple resource blocks, you can use count to create a specified number of instances from a single block of code. And with count.index, you can differentiate each instance. Let's start with a basic example. We are creating resource Google Compute instance and we have given count 3. That means there 3 Google Compute instances will be created. And in the name you can see we have assigned instance dash count.index. And as you know, indexing starts from 0. So the first instance name will be instance 0 and next instance name would be instance 1 and instance 2. So right now we are creating just 3 instances. So we'll have instance 0, instance 1 and instance 2 name. And under metadata, instance ID should also be unique. So we are using count.index. Let's just have a look on some use cases and best practices of count meta argument. Count meta argument quickly creates multiple instances of a resource, such as web servers or databases. Use count index to assign unique names, IP addresses, or configuration parameters. Using count meta argument, you can keep your configuration dry by avoiding repetitive blocks. Let me show you how count meta argument works in a quick hands-on demonstration. Here, let me quickly walk you through how we can utilize count and count index meta argument. So this is my Visual Code editor. Under providers.tf, let me just define providers. I'll use Google provider. So as the prerequisite, I have already created one Terraform service account and I have given some appropriate permissions. Let me show you what permissions I have given so far. Let me just open Google GCP console and click on console in here. So this is my GCP project. Let me just search identity and access management. Click on IAM. Under service accounts, I have created this service account already as the prerequisite and I had created a key and I have downloaded that key. We'll use that key to authenticate on Google Cloud. Here, this is the service account and we have to provide appropriate permission to this service account under IAM. So just click on IAM. I have given so far like storage admin, Kubernetes admin, but in this hands-on demonstration, we are going to create compute engine. So let me just provide compute engine admin role in here. I'm giving broad level permissions, but Google recommends principle of least privileges. You only assign the permission whatever is required. So in your organization environment or on real-time environment, you must provide as least permission as you can. So right now I have given compute admin permission on the service account. So let me just open Visual Code Editor again. And this is the key that I have downloaded from that service account. Let me just create one more file variables.tf. Under here, let me just declare variables for project ID and reason. Variables project ID. Type string. Default value of this GCP project. Copy it and paste it in here. We have to declare one more variable called region. Okay, US Central 1 region. Let's take it to US Central 1 region. This should be correct indentation. Okay, so under providers we have defined remote backend as GCS, and this is the bucket we already have. If I show you, I have already created one bucket. under cloud storage buckets. We have this bucket and we will store our Terraform state in this bucket. All right. So let me just write down one Terraform resource for Google Compute Engine. Google Compute instance, resource name as name. So here we'll provide count as 3, name, instance, count.index, machine type, and one standard one. Let's take it smaller instance type as E2 micro, because this is just the demonstration, so that machine type is fine. John US Central 1, fine. Boot disk as a network interface. So boot disk, we are gonna provide Debian 12. We can define the metadata as well. Metadata, we can define instance dash count.index. Let me just save it. Here, as I have shown you in the example, we are trying to replicate the same. We're going to create 3 Google Compute instances with the unique name. We have taken the machine type as E2-micro. Boot disk would be Debian 12. This is going to be Linux instance, and network interface should be default. So let me just initialize the Terraform working directory with Terraform init command. You must know what Terraform init command does. Terraform init command initializes the current working directory and downloads the necessary provider plugins and modules, and then set up the backend for storing your infrastructure state. So let me just hit enter. Okay. Right, so you can see it's installing the HashiCorp Google Provider plugin. All right, so my Terraform working directory is just initialized, and let me just run Terraform plan. So here you can see there are 3 Terraform resource will get added. So if I just scroll up, and you can see this is the instance 0, name 0, machine type E2 micro, the name would be instance 0, although this is metadata. There should be name as well. All right, yeah, this is the name, instance 0. Okay, this is instance 2, and this is instance 3. Well, the name it is instance 2 because of indexing, because indexing starts from 0. So we are adding 3 instance with a count meta argument. So if I just run Terraform apply -- auto approves, it will not prompt me to approve the apply. It takes some time. In the meanwhile, let me just go to compute engine instance, click on virtual machines. So there is no VM instance created. Let me just switch to visual code editor. So you can see the plan, and plan is started executing. So you can see instance 0, instance 2, instance 1. These are still creating, and let me just switch to compute instance. Yeah, so you can see our instance 2 instance out of 3 created and ready. Let me just refresh. Yeah, so all 3 instances are available. Let me just clean up the lab. I'm gonna destroy all 3 instances, otherwise I'll get unnecessary billing. With Terraform destroy command, Terraform destroy -- auto approve. All right, it is just refreshing state. All right, so now all 3 instances are under deletion. Let me just refresh it. All right, so let's just wait for some time. In the meantime, I'm just pausing this video. Once all these 3 instances will be deleted, I'll come back. In the console, you can see the destruction is complete. All 3 resources are destroyed. If I show you on the Google console and let me refresh the console, so all three instances are gone now. And this is how you can utilize Terraform count meta argument to make your Terraform configuration dry and scalable and avoid repetition of Terraform resource blocks. If you found this video helpful, please do like, share and subscribe, and make sure tap the notification bell so you don't miss any future videos. If you have any doubts, please drop them in the comment section. I would be happy to help. I'll see you in the next video.